What we're going to talk about today, and we're going to show you these new exciting things, are actually some of the new 2.5D machining that has become available to be used inside NX85, as well as all the other enhancements that took place with inside the CAM module, which includes updates and refinements to the toolpath to make the toolpaths much more smoother and much more refined so they cut better. So there's a lot of changes. There's a few changes inside the CMM inspection. We'll talk about those. And then the new products come out for CAM management. So there's a new product that we can go out and actually manage all of our CAM data, including the NC programs, the NC setups, everything down all the way down to the shop floor. So we'll take a look at all that today. So first thing we're going to take a look at, though, is probably the most exciting aspect of the new release of 8.5, which is 2.5D machining. And 2.5D machining is more of a volume-based machining, where it's going to look at what has not been removed away from the part yet, and what needs to still be removed from the part that you're trying to machine. So it's really that we're just selecting the face, and the system's going to analyze it and determine where we need to machine and where we don't need to machine on the parts. So it's like it says, very fast, very intuitive. You're just picking a face. The system's going to update with the in-process workpiece, so it works with the in-process workpiece, and it's great for prismatic parts. People have reported back as much as 5 to 10 times faster in programming methodologies. I've actually programmed parts 50% faster with it, just because I can pick a face, pick a face, pick a face, pick a face, generate, generate, generate. And it really simplifies the selection of the geometry. I'd say it's very, very close to being as good as a first release of new software can be, without taking everybody's considerations for what their part configurations look like. So it's got some it's got capabilities to do your floors as well as the walls with inside the part files. It's fully aware that the in-process workpiece exists, and it's going to use the in-process workpiece to adapt and cut to the in-process workpiece. They also reworked the zig pattern with inside NX, so now it tries to generate a much more refined zig routine inside NX and that goes not just for volume-based machining, but for all of machining with inside NX where we used zig-based machining. We're going to talk about 2.5 also has trim boundary support and all the standard support. If you've ever used face milling, it's very similar to face milling. How should I say? It's very much like face milling with inside NX, except we're using the in-process workpiece. All the operations that were existent before in face milling, some will be converted to be the new processor, and some will stay the old processor. We'll talk about that as we get inside. But as you can see from the images on the right-hand side, that the images actually show you where the toolpath has started machining over on the right-hand side. It's actually avoiding all the in-process workpiece or the part the raw stock that you're trying to make. So it's going to come down and get as close as possible to the starting cut position of where it found a cut level. So it's going to find all the cut levels within inside the part, looking at the part surfaces you picked, looking at the part geometry, and looking at the in-process workpiece. And then it's going to develop an in-process workpiece that follows throughout the entire process. So inside of volume-based machining, we can do floors as well as walls. We can color down the side of the walls in the stair-step motion. All we have to do is flip it from just cut on the floors to cut on walls. So then it will cut, when it does walls, it's going to cut the floors and the walls. Notice it's going to go over into your corner radiuses and machine all the way up to the corner radiuses, all the way up a tapered wall with inside of 2.5D machining. So it's a really, really highly efficient, almost works like cavity milling in some respects in its cut motion. So when we look at the cut region confinement, like I said, we can confine to floors, and the first two slides here are showing the containment being positioned for the floor to cut only at the floors. So it's going to leave all this excess material on the walls. So because it found a corner radius, it's not going to go over and violate the corner radius. But when we say floors and walls, what the system's going to do is take it and push it all the way over to wherever it can find a match up against the wall. So when we turn exact positioning on, it's going to actually push it all the way across to the walls. So exact positioning, when we turn it on, is a little switch which is inside of 2.5, and we're going to see it in a minute when I bring up my parts. It'll push it all the way over to the walls and get an exact positioning up against the walls that goes in and cuts. With it turned off, I should say, exact positioning is going to actually go all the way over and cut to the wall. Then you can actually tell that when you want exact positioning, it's going to go over and cut, and it's going to position, if I get the slide there, when it's turned on, it's going to actually come out and become tangent to wherever that wall, the angled wall is. You can use ball mill tools or bullnose tools as well as taper tools inside the volume-based machine. So let's go ahead and take a look at the 2.5D machine. First thing we're going to take a look at is one of my parts that I have. I have a setup already pre-made here, all set up, ready to go. Standard prismatic style part. It's on one of the machines that are inside of the Siemens folders. So you have all the capabilities to open this machine up and play with this machine. So let's go ahead and take a look at what I've got set up so far. I just have the program group set up as program 1, and I have 3 tools in here to go ahead and cut the part with, and then I have my standard MCS and my workpiece. Now, one thing you're going to notice is the color changes inside of your part files. You're going to see that Siemens is going to color code. They're color coding everything now. So when we select on a piece of geometry over in your navigator, it's going to color code it to a different color than what you've seen in the past. So it lets you know that that is the piece that has been selected inside of the workpiece. Before, it would just, I think, highlight the edges. Or you had to come into the workpiece, and then you had to pick the workpiece and then turn the flashlight on. We don't have to do that anymore. We just pick on the workpiece. It's going to show you the outline or the shape of the block. That would come in different color for the raw stock, as well as the piece that we're trying to machine inside NX. So they've done a lot of enhancements to make the product a lot more user-friendly, faster for you to program inside of NX, which they've done a very excellent job. So the first thing we want to do is actually create a brand new 2.5D machining operation. So I'm going to go ahead and insert a brand new operation. And the first thing you're going to see, it's located off the mill planer dialog. So the first one you're going to see is that these icons up here have kind of changed. They've also shortened up a lot of the icons in some of the processors. So if we look at mill contour, they've taken a couple of the icons off that were really relatively just duplicates of other icons. So they've taken those off. Mill multi-axis, they've really taken quite a few off. So they've tried to make it easier for you to pick, make your template much easier. Now the one thing you're going to notice too is all these pop-ups that start to come up. As soon as I put my cursor over the top of any icon inside of NX, you're going to get a big, large dialog panel that's going to tell you in explanation what that particular icon does, or what that toolpath is going to do for you. So this one is the original floor and wall, where it cuts floors and walls, and it gives you the definition of what it's going to be. And then it tells you it was recommended for basic face milling of planar faces on prismatic parts. It replaces the face milling area operation. So this is the operation. It used to be the old face milling area operation. The next one to it is the one we're going to look at today, which is the floor and wall IPW. So it's the one that is really the new and improved 2.5D machining. Then over here, I mean, each one of the icons is going to come up and kind of give you a much better explanation, easier to use, because you can see it's going to tell you exactly what it's going to do. And you can go through these at your leisure when you've got 8.5 loaded, and you can see all these different panels. Actually, when you create your own custom templates, you can actually load your custom template with this same window and explain to your users in your company, hey, this is what I'm using, and here's the icon, here's what it's used for. So if you have a special one set up to do a rough on the part and leave 50 thousandths that we do as programmers, that icon up there could be a special picture plus a definition of what that icon does. So I'm going to pick on the face milling floor wall IPW, and that's why it's got the name IPW at the end, because it does use the in-process workpiece. So we're going to leave it set for the program name to be program 1. And we're going to pick the big face mill to cut with first because I want to face this part off. We're going to look at the workpiece. That's what the geometry is going to be, and I select OK. So inside, when I hit the flashlight, once again, it's going to show gold. I have to pick a floor. So I'm going to pick the cut area that I want to machine. First thing I do is I come in and I pick here, and I pick over here, and I select OK. Now, also over here, you're going to have tool tips that are going to pop up at different times. If I can get one to pop up, there's one. Instead of opening it up from now on, what Siemens has done is gone to have the tooltip pop up immediately when you put your cursor over the top of an object. So let's go ahead and leave it set the floor. It's going to go ahead and cut the floor, and we'll go ahead and now we'll generate the toolpath. That's just telling me my tool that I'm using is tapered. So now what the system has done is if we go in and look down below, we've got an in-process workpiece. So the system's looking at the part, the raw stock that I gave it as the definition of the blank that we're machining. It also is looking at that, and then it builds a pseudo shape here. I hope you can see it on the screen, the little green area. Well, that's telling me this is the area that it's going to go down to, and it's going to machine off flat with the face mill. So the in-process workpiece then, once we're done machining, this is what it would calculate out to, and that's what it would machine down to. First, we got to generate the toolpath, though, again. We want to change the direction of the cut. We don't want it to go from the front of the machine backwards. So we're going to go in and change the cut angle. Right now, it's set to automatic. As you can see, these images change too. So automatic tries to follow now along. I can't slip over onto the picture. It won't let me do it like I used to be able to. But you can just see that it's going to go automatic and try to find the, usually it still tries to find the longest line and the longest segment that you're trying to machine inside the part. You can also specify it still with a direction of cut. You can say, what's the longest edge? And then you can give it a vector, cut at any orientation. Or you can say two-way vector. I'm just going to go ahead and say specify. And if you don't know, you can grab the ball inside the compass that comes up on inside of NX and just turn it to 90 degrees, or I could have typed in 90 degrees over here. And we'll go ahead and we'll generate this toolpath again. Then we'll take a look at the toolpath inside NX. So I'm just going to play back. And everybody should know that we now have, from earlier versions, we now have holders that have been available for a long time, but we also have shanks that we can apply. I believe that came in NX 8, where we can apply the entire shank definition of the part. So that's the green part's the shank. So what I want to do is just step through real slowly, and you can see that it's going to stay away from the part. It's going to stay away from the blank stock too at the same time, because now we can tell it that we want to stay away from the blank stock. So I'm going to go ahead and select 2D and let it go and cut through it and do a compare. And you can see the top of my stock is now green over here, which means it's good to us programmers. So the next thing I do is go in here. When that surface is finished off, I want to cut this slot, and I'm going to go ahead and insert a new operation. So I'm just going to continue using the floor and wall IPW, pick my 1-inch diameter to get in that slot and cutter. So I'm going to go ahead and select OK. Just pick the floor area that I want to cut, say OK. Now if I pick on floor area, you can see over here that it's turning it green with the flashlight. Turn up here, it's gold, and they still both stay highlighted. So I can see where I'm going to cut, and I can see where the part is at, and I can see where my blank stock is at running around the part. So now what I just have to do is just go ahead and generate that toolpath. So now the toolpath's going to come down, go through it, cut, come out. Okay. Now over here you have cut the walls. So what the system's going to do is it's going to go all the way over to the walls and cut up to the walls too. This slot, and it just moved over a little bit more and got up to the walls. We're going to take a look at another part real quickly in a minute of how we can stair step it kind of. What I want to do is drop it down in depth per cut of 50 thousandths. So now I got a step down of 50 thousandths. Say OK on that toolpath. what we'll do is we'll go ahead and add another toolpath inside of here, another operation, and I'm going to do the back side. Now the machine just got in my way. So what I have to do is I'm going to continue creating this operation. And I'm just going to say OK here and go over to the Assembly Navigator and turn off the display of the machine. You can also turn off the display of the tools so I don't see them. And then the only thing I see is my part. So let's go ahead and just open up the floor and wall here, and we're going to cut this slot out that doesn't have a floor. So what I want to do is, instead of turning on automatic walls, I turn that off, and I come through and I pick the walls. So I want to specify my wall geometry here, here, and over here, and say OK. Once again, I can say here's where it's at, and then I just go ahead and generate the toolpath. Now the system went through, did a zig motion into the toolpath, but maybe I want to do a profile around that entire inside area, so I just go ahead and do a profile. Now what it's telling me here is it's going to turn on the toolpath to be a Z plus tool axis instead of using face normal, because there is no normal face down here. I don't have a floor face in here. So what the system's going to do is going to go ahead and use Z plus and still leave it toggled to normal to face. But if I turn that to Z plus and generate, it does it automatically. So then if we turn around now and just look at the toolpath, and let's go back and turn the machine back on because we can simulate the entire machine. Just got to wait for it to load. Oops, I need to do one thing just to make sure it's going to do what I need it to do. I need to define the fixture. Okay, it is defined. And I want to make sure the part has been defined, which it has been defined. Just got to make sure. Next thing we're going to do is go do the simulation. It's got to reload the blank. And then we just go ahead and play it. Slow it down a little bit. So the machine's going to come down, go across, and cut. I want to speed it up a little bit. Now they've made a lot of improvements to the refinement of the IPW, which we'll talk about after the 2.5D machine. Let's go ahead and speed that up a little bit. Oops. That tells me right there that I need to get a longer holder. The holder isn't, the tool isn't long enough inside the holder. So I can just say continue until reset. And then you're going to see that the cutting edge down here, it's because number one, I didn't step down into the material, which I could have with the IPW by just coming in here and saying depth per cut is 1/4 inch. Then I come back over to my tool, and I notice my tool actually is not long enough as well, so we'll make it a 3-inch tool. And then I'll regenerate the tool path because it has to be regenerated. So now it's stepping down into the part, and I got a good verification back on it telling me that I needed to adjust the way the tool path looked. So then once again, if I just simulate that again, gotta wait for that to update, let it play through fast. And then it's going to play through. To do that the old way with either planar milling with boundaries or face milling, you would have been there quite a lot longer trying to figure out how to get that all to work correctly for you. What I want to do, I'm going to close these parts out, and we're going to go straight over to a more trimmed surface that's inside of the part, so we can show that it actually does go out and trim up against the walls. Throw those up here, and we'll insert a new tool. or a new operation. Once again, I'll pick the operation for the IPW, make sure my mill is picked, and select OK, and just pick the area that I want to cut. So I'm going to let it pick through and pick that face, select OK, and it's going to tell me when I select on the flashlight for the wall geometry that it's found this wall and it's found this wall, because it's done an automatic wall and found where the walls exist. And we're going to be doing a zig pattern through the part. And so it's going to come over in this area. Now, underneath the cut patterns, they give you all the standard cut patterns: follow part, follow periphery, profile, tricodial, zig, zigzag, zig with contour. So if I was doing this as a pocket routine, I'd probably say follow pocket, or excuse me, follow part, follow pocket, one of the two. And then it's going to follow the part in the actual contour that it needs to follow. So I actually need to add some depth to it too, as well, and select OK, and then generate the toolpath. That's a metric part. That needs to be a little bit bigger. Too much toolpath. Let's make a step down to 2. There we go. So now you can see that the toolpath is actually cutting the part out. And we go ahead and play that back really quickly. Let's leave a big post. And there's a couple other switches that I need to probably turn on to make it more efficient. But underneath the cutting parameters for 2.5D machining, you've also got the allow undercutting switch still, where it allows it to undercut in specific areas that you really want it to cut where it shouldn't. That was one of the problems with face milling, that you'd go to cut up against the wall, and if there was a radius there in the corner, you could never get face milling to go all the way over to the corner. So we turn that allow undercutting on, and then it would allow it to go across it. The thing that's different about 2.5D machining is now you got the blank capability for containment. So we can actually tell it we want to do it by 3D in-process workpiece. You want to do it by the blank geometry that exists, or you can give it an offset thickness. So when you say what's the floor thickness, what's the wall thickness, the system will analyze it particularly to whatever thickness you give it. So even though you don't have a blank or a part, you still can use a blank, or you don't have the in-process workpiece, you can go ahead and just put a thickness inside and apply it. To really make the 2.5D work good, you should have a blank, and you should just use the 3D in-process workpiece. Under simplified shapes, I would just say let's do minimum box all the way to the wall, all the way to the box. You can also tell it extend to the walls, the cut regions. Once again, it's just the same switch from the outside. Are you going to do floors? Are you going to do walls? Well, now let's go ahead and set it to walls, and we're going to get a different result because it's going to go all the way out to the edge of the walls. So now you can see that we're getting complete coverage all the way out to the wall, which is really nice. So it kind of behaves almost like a cavity mill does in its process. Let's change that to follow part. And you can see it cuts it, which is really, really sweet. Because it's just pick the face, you're done. Generate toolpath. And if you've already got a template set up with, hey, this one does floors only, this one does walls only, this one has 50,000 stock, and you set your templates up correctly, you're really only just picking geometry at that point, and that's all you ever have to do is just to pick geometry. Let's see if there was anything else in here. We have clearance for tool holders, which becomes more important now that NX has some extremely well tool holder support. The only other switch is to show the in-process workpiece once it's done, completed, and that's what the in-process workpiece would look like once it's completed. So we can use all different kinds of, you can use taper cutters, ball mill cutters, or not ball mill, but I haven't tried a ball mill with it yet. We can do that right now, in case somebody's wondering. I haven't tried it with a ball mill. So what I'll do is I'll go ahead and just try it with a ball mill and copy that operation, paste it inside here, and we'll go back to our program order view, and I'll drag that one out, which is the good one, put it in here and regenerate that toolpath. And it works with ball mills too. So any type of tool, ball mills and bull nose, tapered cutters, any type of cutter that's out there. Let's see, for 2D, just to finish up with 2D here. Let's see, we talked about all that. You can use check geometry as well as trim boundaries. So if you want to isolate a zone out for trim boundaries, you can do that. It's inside the capabilities 2.5D machining. Here's a little snippet that Siemens has given me to show you that if you turn on ignore outside trim and turn it to on, the system's going to ignore the blank now. If you tell it to see the blank, the system's going to recognize that the blank exists. So that's underneath your non-cutting moves. You go in here and say, now you can say ignore blank on the trim side. So when I have something area that's getting trimmed, I can say to ignore the blank, and just go ahead and go in and cut from the blank. So now that's a little switch under your non-cutting moves that's really, really useful. I've used it already. So when I turn it on, it's going to ignore the blank trim area. It's going to ignore the blank like it wasn't there. So that means what happens then is if that stock is actually there, what's going to happen is, if you can see the pink, crash, you're going to put that tool right through that material. And maybe that's not what you want. What you really want is this, for the tool path to come in and go right along the outside of the stock and offsetting the non-cutting moves by the distance from the actual blank stock, and then go down the side of the part. So now it lets you offset from the blank, and that's what it should have been in the beginning, but they got around to putting that in the package for us as well. What they've done too is increase the IPW quality within inside of NX. So now instead of having terrible looking IPWs, which fractured up the surfaces quite a bit and made it a lot more jagged and a lot more reliable when you go to machine with inside of NX, they reworked the entire engine, so they're getting much more smoother results with inside of the processor now instead of the older style IPW. You can also see that this was NX8, so instead of mimicking the shape of an actual radius, you would have multiple facets going up and down the side of the part. And like it says, the IPW has actually been increased. It now uses multiple CPUs, so when it does its calculations, it can use up to 3 cores for its CPU. So all our multiprocessors now go through and just chunk through it a lot faster. So you can see up to 5% or 50% improvement in some of the parts. Aerospace guys have said, and they've been seeing a lot, like 50% improvement. So let's take a quick look at that real. And then we have a part right here that I'm just going to play back. This is the big tool that came in and wrapped, and here's the small tool. And if I tell it to go ahead and use the IPW and play it back in verification mode inside of NX 8.5, oops, I want to use the 3D dynamic and just let it go ahead and go through it. We're going to see that it's going to actually make a lot cleaner, a lot smoother representation of the model inside of NX now than what we've ever had in the past. And they're still working on it to refine it to make it even better. It just takes time to make all those calculations. So I'm just going to hide everything inside here, all solid bodies. So now you can see along the wall that it's a much, much more smoother representation of what that solid body needs to be as we go in. Much cleaner. Much cleaner here too. Plus the calculation time is much faster. You saw it go through that process really quick. In the past, we would always do 2D dynamic. It just seemed like it was always faster. But now the 3D dynamic has speeded up quite a bit. So you can just see how much faster it goes through. Now, if you've got a gigantic part, it's still speeded up for all parts, but it's just relative to the size of the part. And close that one out. So the IPW had a significant rework done to it inside of NX. Next thing we want to take a look at is some of the fixed and variable axis modifications that took place inside of NX. For cavity milling and area milling, what they've gone through and done is a lot of cleanup of the toolpath. So inside of NX8 and previous versions, we'd get a lot of corner areas that the software would have a little bit of problem trying to figure out how to put in the different toolpath motion inside of NX. So what they've gone through and done is really went through and fixed a lot of the processors to do much more refined calculations of these smaller areas that NX needs to go in and look at. So for all of your operations like Z-level machining, 5-axis with Z-level, cavity milling, plunge milling, area milling, they went in and they actually re-enhanced the engine that drives behind the scenes to make this calculation. So now you get a much more refined toolpath than what we ever have in the past. Some of the old toolpaths would also, as you can see, it would leave material in areas that would jagged and go up and all kinds of other weird stuff. So our peripheral cuts actually have changed too with inside of NX. Now we come in and they can actually chase the wall inside of a peripheral cut. So we go through and we, instead of telling it to do this and then come over and finish doing the pocket routine, we can incorporate the entire periphery cut and everything built into one entire toolpath. So that's how the system's going to do it. There really were no UI changes inside of NX8 for those different options. Pretty much everything has stayed the same. The look and the feel is all the same, but the way the toolpath is going to output it, it's going to be much better, much more well refined with inside of NX. You can see here's just another example of localized cutting. And on a part that's very large, what they found out was they were getting problems with the toolpath before NX 8.5 with the way the toolpaths were looked at and then calculated for how the toolpath should get applied to the part. So you get a lot of jagged areas on the part. Now what we've gone to, they've went through and reanalyzed it and found out there's better methods inside of NX8 to actually cut all those different surfaces inside of there. They've also completely significantly enhanced FlowCut. FlowCut before is a great product. It's just that now they've gone in and they've actually had the capability to apply a Z-level toolpath within inside of FlowCut. So when you're going to the mold and die guys, even aerospace, they have to get underneath flanges. We can go in and say for the bottom we want to use the Z-level, the standard lacing type motion inside of all our corner radiuses. But when we're going up a wall, up the side of it, we want to use Z-level. So what they've done is they've incorporated Z-level to be inside of FlowCut so that we can actually trace up the wall and tell it we want to cut this with Z-level and cut this with the standard FlowCut. So it's really been enhanced and it works extremely well. So like it says, it's got the ability to clean up uncut material in deep slots as well as pockets. It's very reliable undercut material recognition and handling, and complete use of reference tool still available built into it. As it looks and analyzes these tight areas, what the system's going to do is say, should I use, you can specify for these areas here that you want to use FlowCut, standard FlowCut, but when we're tracing up the walls, then that's when we want to use Z-cutting. You can come in, also go in and do a manual mode where you can say it'll break it up, and you can say I want to use this manual mode or I want to use that manual mode, and you can flip the tool paths around so that I say I want to do Z cutting here, let's say now, and I break that up from the operation. I can either say I don't want it in the same operation, or I can go in and do in the operation, let's split this up and let me go ahead and reorganize it so this is done first and this is done second, or this is done first and this is done second. So they've kind of added that in there. This is just showing you they consolidated rest material removal with inside of NX. So now this is clearly showing you the Z-level in the FlowCut. So here's the dialog. Non-steep, we're going to go ahead and do a zigzag with lift. So we're going to go around here and zigzag it. But then when we go to do the steeper areas, let's go ahead and do a level zigzag. So it's going to come in and cut with level zig motion. That's the three that were added down at the bottom. Z-level zig, Z-level zag, and Z-level zig with lifts. You get true ref tool selection now, so you can come in and actually pick the tool that was used in the operation before. Ball mills and bull mills reference tools now, so you can use both of those. Improved it also improves on the rollover for the edge. Let's just take a quick look at some of these operations, and I'll show you what some of them actually have increased to. So when we go and look at a before NX8 operation, this is the toolpath using area milling. You can see all the jagged motion, and I'm sure everybody's seen it and been dismayed that the toolpath was going to look like that. But then now inside of NX8, our toolpath is going to look much more refined, cleaner, no jagged shapes. Over here we're going to get a much smoother shape. So it's trying to follow the shape of the part much cleaner, and it gives you much better results instead of the old NX8, which produces all these terrible looking spikes in the toolpath. So if this toolpath was just regenerated and it was an old NX8 operation, I would just go ahead and generate that toolpath. These are things that you don't have to do yourself. They're just functions that have been incorporated into the processor, and you don't even have to do anything. The system's going to automatically create a better toolpath. And as you see, it just created the toolpath, and it shows you from that older toolpath to the newer toolpath. Just a simple regeneration is going to give you a much better surface cut. Let's take a look at this toolpath over here. This is just doing some flow cut with cross-sectional cuts. It could be done multiple ways. So when I select on flow cut, what we're going to see down in here is flow cut also has the same stuff we used to have before, where you can go in and cut with zigzag, zig with lip. But now you can come down and say non-steep areas are cut with a level zig or level zigzag or level zig with lifts. You can also do the steep that way. So if I say cut steep with that method, then also use the reference tool. You can select any tool in here, any ball mill, any end mill, and select OK, and it's going to refine it and cut it better. So now you can see it's going through, and it did all the reference tool, and it did its trace lines, and now it's going to come back and analyze and say, hey, how do you want to cut? So now you can see we get a much better cut going in between the part. Very much highly needed improvement to the processor. That's correct. All the options in here have stayed the same. You can use in-process workpiece with it too as well. So the blank can be checked, and you'd only be cutting in the same location, but that was always in there anyway. All the other dialogues have pretty much stayed the same. So no, there's no new additional drive methods inside of surface machining. Same drive methods that we had available before. So go ahead and close this out. I think I had this one. This is just a cavity mill. This is Z-level today with cavity mill. They've done a refinement to the processor to try to make sure that it understands you don't want to jump off of areas and jump and re-engage back to those areas. So this is what it looks like today with a toolpath. So it's going to jump off at each one of these corners. Now when you come back in here and select the corner refinement with inside of the product, it's going to go out and refine the corners and make it not jump around as much as what it was doing. It's going to refine it a lot more, take out a lot more of those different steps. As you see, it took them out down here. So it's not going to jump out away from the part as much. Same thing happens here. If you go ahead and regenerate this operation, it's going to update it to the new Z level. So it took a lot of the motion out that it could find, and they're still refining it still today as we speak. They're still going in and making sure it's better. So instead of that, you're going to end up with a much more well-refined toolpath. So that's just something that's internal to NX. It's nothing that you have to do yourself. You don't have to turn any switches on or anything. That's built into the software. So that's what they changed to. So if you see better toolpaths, it's because they've gone and created better algorithms to go through and analyze the part. So next thing to take a look at is variable axis contouring. So for us 5-axis programmers, for aerospace parts or any kind of parts, the contour profile dialog, contour profile got a complete rework. Most of the time it was an I don't want to say unusable product, but because it only had a few locations where it was really, really successful in how it would cut. But now they've got it so that you can actually use this for all types of machining now. Here's what it would look like in the past. It would spike up and down the wall when it came to different edges. It would just jump off of the part in certain locations. But now what they've done is they've gone through and added some more tool axis control, better capability for when it incorporates a blank distance across the part. So it's been refined so that the tool path actually just goes and cuts across the voids, follows either the UV of the direction of the gridding that you've created, or it actually goes in and actually follows edges that you want it to follow. So the system has gotten much more robust. What they also added was ring height control, so that as the tool is coming up this wall, this is a circular type wall or a round wall. As it goes up, you can define where your ring height is on the part, and the tool is going to stay tangent at that tool point back to the surface that you're trying to machine. So they just added this inside a contour profile, so that we've had that in sequential mill, but it was always harder to do in sequential mill because contour profile is more of an automated product. So let's take a look at that really quickly. And I just want to this is how we would have done a standard aircraft part years ago with sequential mill. So we would go in with sequential mill and tell the processor, hey, I want to pick this wall and walk all the way around it. So what they're trying to do is get the processors for contour milling to actually go in and just detect all these walls and detect all the floors. So what I'm going to do is go ahead and pick a new mill multi-axis operation, and you can see you still have your sequential mill. It's a great product. Z-level 5-axis machine. That's still in there. Fixed axis contouring, but here's the contour profile. And I'm going to go ahead and I'm going to pick this tool. Let's use that undersized carbide. And then go ahead and I got to see where my geometry is going to go. Got a couple pieces of geometry in here. Main work piece. That'll be good. And I'll select OK. So the next thing we do is we look at the contour dialog. What's really changed in here a lot is that the tool axis controls now can, instead of just being automatic, and it tried to determine where it was at, you can also do align to edges when the surfaces are picked. It's going to align to the wall's edges. Or you can do a swarf to the UV grid direction. I typically leave it automatic now and try to see if that's going to get what I need. All you have to do is come in and specify the floor for the product. And there's the floor. And the system should walk around the part because it finds automatic walls, detects all the walls in the part. And now all you should have to do is generate the toolpath. And now what the processor's done is it's gone. Now, I'm going to go ahead and fix this because out of the box, the non-cutting moves are set up to come straight down. So your engage is set to linear. It should actually be something like an arc normal to tool axis, and these two should be set to this look at the open area or look at the open area. Retract should be the same as engage. And then when I regenerate, it'll radius into the wall and radius out to the wall. So the selection of the geometry, you don't have to do it except for picking one face. Bam, and the software will automatically detect all the surfaces that run around the the pocket. You can also do multi-depth offset with it, just like we could before. So select the wrench. If you want it to cut across the wall's gaps, you say cut across it. If you want to step over it, step over. If I want it to go. Because here's what always was the problem. In this location here, this material maybe wasn't removed yet. And you just wanted the processor to go across the wall. It wouldn't do that. It would always just come to the edge of the wall, come off, and go across it. You could change your start point and end point. That's been reworked, so it's defined slightly different. That inside the start points and end points, typically what I do is I divide the wall, and then I move my point. Let's see, it's going to cutting parameters, and let's just do multiple passes for depth. So when I put my cursor over the top of multiple depths, you see the little image comes up. I don't remember what the height is for the part. So we'll just do an analysis, measure distance. I'm going to do a projected distance, find out what that distance from the top to the bottom floor is, 2.45. So my depth stock, 2.45. It will increment it at 1/4 inch with our step down. Say OK. Generate the tool path. And it's going to make its cuts passes through it. This takes time for the calculation to be made. As you see, I turned the switch to tell it when it found a gap, jump over the gap, and that's what it's doing. It's calculating out the gaps and it's calculating the cut motion. So let's close that one out real quick. And then let's see, I got this one here I would like to take a look at real quickly. Inside of here we have multiple types of tool path. When you're doing a floor and wall finish here pass, let's go into verify mode. This is using the ring height now. So what the software is going to do is it's going to look at wherever that ring height is at, and it's going to position the side of the tool to the side of the surface that we're trying to machine. So if we go back and we play just this one back in verification, it would look different than if you're trying to bring the tool all the way from the bottom of the part. And as you can see, it's gonna leave a wider, longer scallop in the location. So it just depends upon what you'd make for your tolerance for your step over. So that was incorporated into the product. Take a look here. So in turbo blade machining, we had a lot of enhancements too. Don't have time to go through all of them because I made a significant amount of enhancements. As we're going through a slot, they've given you the ability to reduce the load being applied to the tool. So it's going to try to slot in special slotting motion to get down into those surfaces that you're trying to machine. They've also reworked the swerving motion that's done along the side of a tool. So it's going to align more to the blade's profile than it did in the past. It's going to also accept multiple patches for surfaces inside of turbo blade machining. The big thing that they added was the lead to trailing edge and the trailing to lead edge inside of it. So now we can explicitly come in and say that we want to control the zigzag motions across it. And hopefully it'll help it from digging into the material too much. And then let's see, inside of there they've also incorporated opposing sided for finishing, so we can come in and finish both sides at the same time if that's what you want to do now. So it's used, like it says, for roughing and finishing multi-depth segments. So you're going to rough, then you can come in and finish along the blade walls. You can also use check stock now for adjacent blade blend or blades to make sure the tool path doesn't crash into the side of the part. The processor now finds much more smoother ways to get through the part areas. As you can see, it had some problems in MX8 trying to get through these smoother areas where it's rolling up the side of the part here, and it's got to roll around the blend here. So the calculations have been adjusted so that now the toolpath just follows along that entire surface at the same time. So the calculations are all internal. You wouldn't see the calculations. They also incorporated better step-over quality with inside NX to make the path more uniform across the path. So it also helps to reduce machining time because the paths are more uniform, and you don't have to mess around with it, trying to calculate it out. Real quick, here's the demo for the Blisk. As you can see, for slotting now, that slotting motion, the tool path's going to go through, and it's got to get down to this level to start machining. But now we can tell it that we want to do an enhanced roughing routine to get down to that surface, so it just doesn't come in and clonk right into the material. And then here's an example of blades with opposing blend sides, or opposing sides, where the system's going to allow it to come in, do this big radius arc off, and come back in and re-engage to the other blade side and come through and cut on the other side. And just here's another showing there's no machine limit. Here's maximum A axis. Here's an example of just roughing to a level, so we can come in and rough straight down to the level and machine it. Here's a blade swarf, just showing the tool path swarfing around the part. It's been enhanced. As you can see, it's swarfing with the blade, following it all the way around the blade. So some of the other milling enhancements that have taken place inside of NX is they've added the capability for the tilting to be controlled inside of NX a little bit better, so that we can avoid collisions with other pieces of check geometry and other pieces of part geometry that exist in the model. So you can take a 3-axis tool path, 2.5-axis tool path, and turn it into a 5-axis tool path, but it will allow you to step over without crashing into the actual surface. I'll take a look at that in a minute. I just want to talk about a couple more slides here. Streamline toolpath has been enhanced. If you ever tried to use Streamline, you notice you got this result in the system. This was due to a limitation in the software where they had made the default 100. Now you can control the default's now 1000, so we put more points around that location, so it's going to follow it much more smoother as it goes around. The control was taken out of your hands, and it was just made and set to 100. Now the control has been set to 1000. That's underneath Streamline's toolpath under the More tab. So the cut step has now been made whatever you want to set it to. Also inside NX, the behavior on a small surface area has been where they found they had finish issues, so they've increased the amount of points that go across these small, tiny areas. That's just something you won't see. It's just something the software is going to do. So if I take a look at this 3-axis tilt operation real quickly, inside of NX, say OK, brings the machine in. This operation has a tool path that has not been tilted yet. When I look at it and verify it, it's going to be running into the clamp. It could potentially be running into the part. So we have an issue here where we need to get this tool path tilted. So inside of NX, they developed the tool path to come in and tilt over on the axis. So now when we go to look at the tool path tilted, it's going to tilt as much as it needs to avoid all these clamps and whatever overhangs might be in a piece of part geometry. So if I take it and let it run slowly through simulation visualization, you'll see it's constantly tilting and readjusting to avoid all those collisions. Now when it gets closer to the middle, and once it can stay up in a 3-axis, 2.5-axis motion, the tool axis will just lock itself at a standard Z-axis. And you see it gets closer to the middle, gets closer, gets closer. The tilt is less and less, because the less tilt you have, the better off you are when you're machining. So then finally it just locks itself in at standard Z-axis machining. To do that is to just actually come in and pick the operation, right mouse button on it, and say tool path, tilt the tool axis. So then you have to say what's the preferred tilt from the fixed axis, and then maintain current tilt between collisions, and it can maintain all the collisions checks. So I'm just going to put in 30 degrees here. And select OK. So this option has been added so you can develop a tool path inside NX. It was once a 2-axis operation, 2.5, 3-axis operation, and now it's going to redevelop it so it becomes a 3-axis operation. The only thing that you have to recognize is if you try to edit it, I should say if you try to retilt it to a different tilt, that it's going to tell you that the selected tool must have a fixed tool axis. It already understands that it's been done once. So what you have to redo is you have to come back in here and do a tool path generation. So I'd have to overwrite that tool path that exists. It temporarily understands that it's been locked, so you have to come back in, and now it creates a tool axis, which is completely locked, or completely 2.5 axis. So you'd have to redo the tool path. Tilt axis.
Real quick, Mike, we do have a question on this.
Sure.
Will this work with bullnose end mill?
Actually, I've never tried it with a bullnose, but we can do that right now. I've always tried it with ball. Let's go ahead and try that. I've never tried that with a bullnose or bullnose. That's a good question. I'm just going to pull a hold around library too as well. And I believe it's that one. So we'll copy this and just put it in here. So I just copied the operation. I'm going to paste it inside here. Then go over, look at the view. Here's the operation. And I'll just generate the operation with the bullnose. Of course, that's a sharp blend cutter. I don't think I put a blend radius on it. As a matter of fact, let me do that. So I put a little corner radius on it. There should be no CRAD on here. So we'll put something like 120 corner radius. So let's make it 1/4 inch. Change that to on part. Much faster. So now let's go ahead and say OK here, and let's do a tool path verification. There. It's going to go through it. And then we'll go ahead and tilt it now. Yep, right there. It tells me it has to be a ball mill. So it must be a ball mill. So it could not be a bullnose. Good question. Something I learned today. So then you just tilt it, and then you have to regenerate in order to get back the tool path that you had. And then you can reapply the tilt to it after you've done that. Very good question. For those of you that do feature-based recognition, some enhancements have taken place. The feature recognition for features that would have an area that the tool path can't get it, the feature recognition can't get in, like if you're putting a hole inside of a part, this area here is open to the right, but the area to the left is closed because there's a wall there or there's something obstructing it. The software now understands that it should be trying to pick this vector. But you can change it for other reasons that this direction direction needs to be this way. You can manually change it. They found out that most of the time, 99% of the time, everybody wants to access it from the open side and not from a closed side where you might be unable to obtain a free access to the part. So they aligned and did a lot of work with their coordinate systems for accessibility into the part. And it's been ported back to NX7.5 as well as 8.0. So the machining direction has been redefined and reworked and respecified a little bit. So they've also added in the capability to specify a vector off of a surface. So what the system will do is when you specify that vector, it'll say, I want to find all the features with this specification of this vector. So it would find this feature and it would find the feature next to it at the same time. But it wouldn't find any other features in here because they don't lie on the same vector inside of feature-based machining. So they did apply that into the software. This is just showing access direction help. So you'd want to access the direction for the vector coming from this side, not from that side. So the rework of the CSYS for the system actually enhanced. They've also added the capability. At that point, they've added the capability, since they did that direction vector change, they had to say which way are you coming from. So you can say I'm coming from away from that point. You can pick a point, and then you can say I'm actually on the inside cutting instead of the outside cutting. So you can still control it, is what I'm getting towards. Same here, just from an axis. You can either do it from a point or from an axis. CMM inspection had a few changes applied to it. What they've done is they've applied an improved collision detection. So when you're in here probing, it automatically tries to resolve the issue of why it's crashing and help you to fix it, so you don't have to go in and fix it. It knows where the part's at. It knows what point it's supposed to be fixing. So they've gone to try to fix it through automatic resolving of the detection of the collision. So you really don't just have to specify the points. You don't have to specify all the collision detection within inside of it. They also gave you new capabilities to do read back for measurement data. So now it really meets industry standards. Turning had some changes applied to it. Let's just go through the slides. There's been some changes to turning. Blank contour zig has now been applied. So what the system does, instead of following the parts outline, it follows the blanks shape outline as it's cutting. Some people were asking for that. So underneath strategy, instead of linear zig, you just say blank contour zig, and what it'll do is follow the contour of the shape of the blank stock, because following the blank stock gives you a uniform cut. Following it from the offset from the part doesn't necessarily give you the uniform and constant chip load as you're going across the part surface up here. So that's why people are asking for it. Just another example of follow blank stock. So it's following the blank shape, trying to remove the material from the blank. What you have to do is have to switch it to blank shape, and then down below you have to give it the depth and the number of levels as a setting. So you have to tell what's the depth you want to go, and then how many levels do you want to cut. Some enhancements too they made for roughing. You won't see it because it automatically does it, but you used to sometimes go across the top of the part, but the improvements to the roughing process are now, like it says, prevents recutting the areas that were already cut once. Sometimes it would skim across the top, so now it just comes in and cuts where it needs to cut inside the processor. You've also got more improved calculation of your cut levels, leaving less material to come in and get finished. So the processor at one point would leave excess material, like you can see up here as well as up here. So now the processor, when you're using a variable average and variable maximum, it would leave excess material primarily. So you can come in here now and it will do a much better calculation and clean it completely up so you don't leave that excess material. We've also got avoidance for clearance for 2-point tangents when you got a condition where you have 2-point tangent cutting. So now in the system, the 2-point tangent is going to allow you to engage, retract automatically. It's going to detect your avoidance collisions during your engage and retracts. Here's an example of they've changed this extend and start towards center. So we can control this a little bit more than what we used to not have any control over before. When you don't extend it, it does not extend the cut. When you extend until the containment's now been chosen, it's going to extend it all the way up to the containment. Or you can extend until you want to go from chamfers and rounds, it will go in and cut all the way up from the chamfers and the rounds. So that was established in the software too and changed. They also applied the stop position for towards corners. So now you can specify where you want that corner to stop at. So under stopping position inside the cutting parameters and turning module, just select how you want that point to be established. So it allows for stopping based on cut fillets, distance, percentage of cut, at a specific point that you just go out and pick. And then you can tell how you want it to cut. Just another example of showing stop positions. One using cut fillets with diameters, cut fillet none. So you'll see the materials left when none is selected. It just goes down to the edge and pulls out. Cut fillets are split, so it's going to cut from one side, cut from the other side, and split it right in the middle and cut in the middle. And then you can say cut with faces, so it's going to cut to that face, and then it's going to come back and cut from that face. And then here's the distance. It's going to allow you to say what the distance is going to be that you want the stopping position to be. So it's going to come in and cut, pull off, come in and cut at that position. And here's stopping position percentage and stopping position point. We've also got improved the IPW calculations inside of the software, so for mill turns. So you have the old situation was turning IPW contour modified in areas that were not affected by drilling or milling. And you can see down here that was not affected, and it would sometimes show up as bad. But now in NX8 it doesn't show up because they fixed it. The tracking points of automatic option, like they've added, computes a suitable tracking point P cluster value now to propagate it to a new toolpath and NC output. So this is pretty big, where they now allow you to fix it, rotate with a holder, or let the P tracking point be automatically calculated. So here's your tracking cluster. And as you go through, here's the initial situation. You want to flip it around the holder. It's being calculated by P3. When we flip it, we still want it to be calculated by P3. It needs to reorient and flip around the tracking holder. You can also show rotate with holder. So if you do a P3, you want to rotate it. We're rotating it. Now it's rotating to P8. So the tracking points have been adjusted so that when you're using a tool in a different tool path and you rotate the tool around, you have much more control with the tracking. The IPW selection, I'm going to try to hurry up because I know it's getting a little later. So the IPW now is selectable, so you can do a measurement between the IPW and the area. You also get a nice work plane that shows the work plane of the lathe inside of the view when you select on the MCS. The last thing to talk about really is that we've now added what we call MRL, which is the Manufacturing Resource Library inside of Teamcenter. The Manufacturing Resource Library is a fantastic tool that can manage all of your tooling database requirements for your shop. So we can come in and build all the tools inside of NX or inside of Teamcenter, put them all together and build the tools all within inside of Teamcenter. So the software allows you to find out what tool is going to be the best tool to cut for your job. Where's the tools located? You don't have to go around the shop I should already know what tools I have in my database in my crib. So I should have all those tools already pre-done, pre-modeled, at least gotten the information from like Sandvik or Valinite or whoever that's out there, and taken the tools and assembled the tools into a usable format so I can see the tool in the holder and everything applied, so that when I know I go to cut, I know what I'm cutting with when I go out to the machine shop floor with my program. So the MRL just allows you to bring all this information together, as well as your heads, your tools, your inserts, everything that needs to be brought together is stored in the database, and then it's just literally just put together, and this is what I use. Like it says, it allows you to easily manage, find, and use the manufacturing resources that us as NC programmers need to use inside the shop. So instead of a simple looking tool, you might be seeing, actually, this is what my tool actually looks like in the machine shop. So we can actually show the tools. Here's just a full tooling workflow. So the first thing to do is to select a tooling catalog that you're going to work with. A lot of tooling catalogs are getting on board with it, and they're putting their data out inside the database, like Sandvik, ISCAR, a lot of different tooling manufacturers. So you'll go out and you'll create, you'll have the tool and vendor catalog, then you'll come into the customer components and you'll see all the components, and then you put the component all together and assemble it, and then once it's assembled, it can be used inside of your CAM operations so that it's tracked that this tool is being used, and the person on the shop floor knows that this is the tooling that needs to be used for my part catalog. So it's basically 1, 2, 3. A lot of companies are getting on board with it. Kennametal and Sandvik, I believe, are already on board. ISCAR might be on board. There's several that are on board with supplying back that information for our NX Teamcenter information. So typically what you do is, here's just the user interface for it. You'll see the tools with all the definitions of what the distances are for the tools, the critical dimensions on the tools, and then you'll see an example of what the tool looks like. And when we go into NX, it's going to, here's all the tool library attributes. Here's just the schematic of the drawings of the tools, and then there's the 3D models. And we'll just use the 3D models inside of NX. You can either show this tool as a spinning or a non-spinning when it's inside of NX and it's cutting. So typically it would be non-spinning inside of NX. We also have Shop Floor Connect for Teamcenter, which will take and push the programs out to the machine tool and make it more centralized, so everybody all the tools are stored in Teamcenter database, all the operations are stored, all the programs are created and put inside there, all the tooling for perishable tools as well as your fixtures, that's all stored within inside of Teamcenter. It then makes it easier to just push it. Whatever the person in the shop, who might be your foreman, wants to look at the data, he can open up anything and take a look at it. Any questions?
No, we don't have any that came across yet. Just a reminder, I'll be posting this on YouTube. I'll send you all out an email so you can go over it again when you need to. I'm very sorry for going over the amount of time, but I mean, there's just lots of cool stuff that we wanted to show you. Still no questions coming in, so I think we can just go ahead and wrap it up. Thank you all for coming.
Thanks, everybody. Have a good Christmas and happy holidays, and I'll be talking to you a little later.